Hello, everyone. Welcome to the Understanding Pre-Painted Metal webinar, which is presented by Steelscape. This is another in our series of webinars from Metal Architecture Magazine. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture, and I'm glad you've joined us. In just a moment, I'll turn things over to Michelle Vondran, our speaker today. First, I want to go through how things are going to proceed. Michelle's got about an hour worth of material, but we have carved out room for questions at the end of each of the 4 sections and at the end of the webinar. If you have questions, you can submit them through your program interface there. I'll monitor the questions and then at the end of each section raise the questions with Michelle. Tomorrow, you're going to receive a follow-up email with links to more information about this webinar that's going to include a video of the webinar as well as a link to download the presentation. I know a number of you will have questions about that. For those of you looking to earn CEUs, Steelscape will send a report on attendance to AIA for those who supplied an AIA number. And if you need a certificate for some other professional development requirement, you can follow up tomorrow's email. But now let me turn things over to Michelle. Michelle Vondran is the technical manager for NS BlueScope Coated Products, North America. She graduated from California Polytechnic State University, San Luis Obispo, with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, and that's later it became BASF, Coil Coatings, with a focus on polymers. This position also included lab development as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roofing Rating Council and Energy Star Roofing Program. She joined Steelscape as a quality engineer for the Rancho Cucamonga paint line, and while there, she has held the quality systems manager role and is now technical manager. Michelle oversees quality systems and technical service for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. Michelle is an active member of the National Coil Coaters Association. She sits on the technical committee, as well as the Zinc Aluminum Coaters Association. Michelle, glad you've joined us and looking forward to your presentation. Take it away.
Thank you, Paul. Appreciate it. Welcome, everyone. Thanks for joining us today. As Paul stated, we're going to go through an understanding of pre-painted metal, what that is, how it's made, and with a real focus on the paint itself, specifically for exterior building use will be our focus. So a couple reminders here. This is an HSW credit. Steelscape is a registered provider of AIA-approved continuing education, and there was no prerequisites for this session that we're going to do today. So the 4 sections that we've broken this into is understanding pre-painted metal fundamentals, the paint application process. Then we're going to move into the 3 common types of paint that are used for building products. We'll talk about some enhancements and customization that can be done around specific project needs or environments. And then at the end, we'll wrap up with talking about durability, performance, and warranty considerations for this type of product. So what is pre-painted metal? It's just that. It's giant rolls of steel or aluminum, which have their paint applied in a factory setting, baked on and cured. And then they go on to be formed into panels, pieces, and parts after they've been painted. It's not all the same. There's a lot of considerations, which we're going to go through today. So to start, a question for you all. How is paint applied to metal for the majority of building applications? There's really 4 types of paint application that most people know: air, sprayed on, dipping, rolling, and brushing. And the answer is rolling. This is actually a picture of what coil coating or pre-painted metal coating looks like. This is not rollers like we use in our house to roll on house paint. Much larger scale, much faster, much more dynamic, but that is an example of what it looks like. What we have here is an example of a very standard pre-painted metal line, or coil coating line as they're often referred to. This is from the National Coil Coaters Association, the NCCA. So we take these, it's a continuous process. We actually attach the end of one coil to the next and keep running in a continuous fashion. We clean the coating first. We then usually add a pretreatment and then a primer and then finally the top coat or the paint that is seen on the finished building. A lot of different coatings that are used, backers, primers, and top coats. We're going to get into those later on in more detail. So the speeds of these lines are quite fast. Typically 100 feet per minute up to 700 feet per minute. I would say that the average coil line in the U.S. runs at about 300 to 500 feet per minute, so very quick. From the time of paint application until the paint is completely dried and cured is only about 15 to 30 seconds. By comparison, your average automobile painting process at initial assembly takes 30 minutes to 2 hours. This is the quickest industrial coating process there is, and we're also applying the thinnest amount of paint of any industrial coating process on metal. If you want to look at videos, you can Google or search online for coil coating videos, but NCCA also has some really nice pictures and videos to watch, and you can see just how dynamic and fast this is. So why do we do this? Why coil coating? Why pre-painted metal? There's several advantages to this. The cleaning and the prepping of the metal is very tightly controlled. You get a really good adhesion of the coating to the substrate. It's fast, it's economical, and we're getting very efficient use of the paint. Typically, the total paint system, including backer and top side, is only about 1.4 mils thick. This is very, very thin compared to most industrial coatings, which are 2 to 5 mils in thickness. Cars are usually 5 to 8 mils in thickness in coating. As a comparison, your average copier paper is actually 2 to 3 times thicker than the paint that we're putting on these substrates.
Michelle?
Yes?
Michelle, could you move the microphone away from your mouth just a little bit? We're picking up a lot of background noise.
That better?
That's better. Thank you.
Thank you. Sorry about that. Now, since these coils of steel and aluminum are painted ahead of time, the paint is really important in that it has to be able to survive the fabrication process afterwards. So it's got to be hard, durable, but also very flexible. So there's a lot of science that goes into the paint and the paint formulations. I promise I won't make any of you do any chemistry today, so it's my guarantee to you. But we might use some chemical terms, but no chemistry. It is a closed-loop system. These are solvent-based paints. They're not water-based, but we do capture all the VOCs and the solvents, which are incinerated and then used to refuel the ovens or destroyed so that we're not releasing anything out to the environment. Now, although this is a great process, there are a few limitations which warrant some discussion. So it's very rapid once going, very fast and continuous. So there's a lot of setup involved. There's a lot of moving parts, obviously very large equipment, and it's based on efficiencies of scale. So we like to run large orders at once, whole coils, which can restrict the color palette that most end fabricators offer. So doing short custom work is not ideal. It can be done, but it's not preferred. So for instance, an average paint line holds from start to finish about 25 to 3,500 linear feet of metal at a time. So running smaller quantities than that becomes a bit of a challenge in this process. Talk about the quality control a little bit. This process, because it is so tightly controlled and is so consistent from run to run and throughout a coil, the quality control is really important. And like we said, these coatings have to withstand a lot once they leave and go to get formed and then get installed on a building. So we run a lot of tests off the line, a T-bend test and a reverse impact test, which simulate forming and shaping of the final product. We want to make sure that the paint adheres like it's supposed to. We test color consistency. It's very important in the final product, the aesthetics. We look at gloss and film thickness. Film thickness is critical not only for color control, but also warranty performance that we'll discuss later. And there's some examples there. So failing impact test on the left and a passing on the right, we actually apply a piece of tape to that bump and pull it off quickly to see if the paint comes off or not. While the focus today is going to be on paint, I do want to talk a little bit about the whole system here for reference. So some are a cross-section of what we've got here. You've got base steel or aluminum, which is your substrate. If it's steel, there's almost always a metallic coating on top of that for corrosion protection. Then we put down the pre-treatment on both sides. That helps etch the surface and prepare it to take the paint. And then there's a primer that goes on both sides. This the primer does a couple things. It provides a good adhesion for the top coat. It also contributes to corrosion protection and formability of the final product. And then, of course, we have the final top coat, which is the color coat, usually, the part that's going to be seen in the final fabrication. You can apply clear coats and some other additional coats as well for protection and special appearances. So metallic coatings, I want to talk about real quick. There's whole courses just on this. It's a subject unto itself, but the two typical metallic coatings that we see in coated steel is galvanized and aluminum zinc. Galvanized is 100% zinc coating. It has to be added so that the steel doesn't rust. And then the aluminum zinc, 55% aluminum zinc, which is commonly known as galvalume or zincalume in the industry. The addition of aluminum provides really enhanced corrosion protection. 55% has been determined the optimal ratio for that. And it's inert. The aluminum is inert. The zinc is sacrificial. So the galvalume product is a licensed product, as is the zincalume product. If you're calling your product galvalume or zincalume, you have to have a license from an organization called the BIEC. Almost all license holders are providing 20 to 25-year corrosion warranties on the substrate for this product, so that separates it from galvanized and some other coated metals that are out there, and then it has a warranty to back it up. And one thing that's important to mention is that there's a lot of aluminum zinc substrate out there, but if it doesn't have the galvalume name, it's not registered and it's not licensed and may not be warranted. Something to keep in mind. So now on to paint, which is sort of the focus of the rest of the time we have here. What is paint? Well, I mean, I think most of us have gotten some familiarity with paint and have dealt with paint in the past in some form, probably in our houses more than anywhere else. But, you know, it's a liquid designed for application to a surface and a thin film that then cures to a solid film. Usually does two things. It's either protecting the surface or creating some kind of desired look or aesthetic. And again, there's many different methods for doing this: brushing, dipping, spraying, vacuum coating, and roll coating. There's four primary components of paint that are important that we're going to cover here today. The first being the resin or the polymer. It goes by both names. This is what we call the binder of the paint. It's the backbone of the paint. Really determines the key physical and chemical properties that coating is going to have. It's also called the chemistry of the paint. Next is pigment. Obviously, pigment's a giant part of what you guys do and how you design and how you want a building to look. So we need that color and those aesthetics to be exactly what we want. The solvents are necessary to keep all the solid resins and pigments in solution and make it suitable for application. And then there's additives that get put in, especially for exterior building use. There are transparent sun protection particles that go in, flow adds, things that help with flexibility. We sometimes call that wonder dust, but they're important. So again, this is sort of how each one of these contributes to the overall paint. Again, the resin really plays the biggest part. It's really going to impact durability and performance in the field. the pigments as well a little bit, but more for look. And then solvents are really just for us to be able to handle it in a liquid form until it's finished and cured. This is a breakdown by weight of those 4 components. You can see that the vast majority is the pigments, the solvents, and the resins, and a little bit of additives. So how do we select the right paint, right? There's a million choices out there. You can see that even if you just go to Home Depot and look at house paint, there's 1,000 choices. Quite the same for industrial coatings and coil coatings. There's a lot to take into consideration. You need the right balance of all the ingredients to give you the right properties for the end use. So you get the right adhesion, you get the right color, you get the right gloss. Cost is certainly a big factor, and then warranty and performance. So it ranges from very soft, very flexible, to very hard and brittle. And depending on the specific end use that the paint's going to go to, or the coated metal is going to be used in, you sort of have to do some trade-offs to reach, a happy medium. The coatings we're talking about today for roofing and walls primarily tend to shift to the harder side. They have to be quite scratch resistant and durable to withstand forming, and then to hold up long-term out in the environment. So you do sacrifice a little bit of flexibility and some other things to do that. So pigments and color. This is what everyone sees. This is the part that the consumer sees, that you, the architects, see, and the designers see. These are insoluble solid particles, finely dispersed and mixed with the resin or the polymer to get a nice consistent color and look. We use 2 kinds of pigments, organic and inorganic. The inorganic pigments are typically your more earth tones, your duller yellows, reds, greens, browns. These are iron oxides primarily. Organic pigments are your brighter, truer colors, your reds, your greens, violets. Most of what's in the picture there would be an organic pigment, very vibrant. So organic pigments provide a very nice look, but they tend to be quite a bit less durable than the inorganic pigments and don't hold up well. They fade very easy. So the bulk of the pigmentation used in exterior coatings is inorganic in nature. So talk about color. As important as color is, so color is the eye's perception, obviously, of visible wavelengths. We measure this as an LAB number numerically. The finished product, as it comes off the paint line, is always assessed both visually against a reference standard, but also numerically on a computer, which allows us to get very good consistency and exact color matches from run to run. So now we're going to move into sort of there's 3 common paint types used for exterior buildings. See if any of you can name them. So the 3 are polyester, silicone modified polyesters, and then fluorocarbon or PVDF. Also goes by the name Kynar. Some of you might be more familiar with that. For some reason, we as an industry haven't decided on just one name for that paint system. So we like to create a little bit of confusion for everyone. These are sort of listed good to best as far as performance and warranty out in the field. So polyesters are sort of the workhorse of the paint world, and then silicone modified polyesters are sort of a step up, been enhanced a bit, and then the fluorocarbons, PVDF, there's all the names, Kynar 500, Hylar 5000, that's usually spec for architectural projects. You move up. So polyesters, like I said, really are the workhorses. They've got they can be formulated in a lot of different ways. They're very cost effective. They tend to be very flexible. They can have a wide range of hardness, wide range of color and gloss options, and they're very versatile. But their performance long-term maybe not ideal for certain applications. So we see polyesters a lot in gutters, downspouts, agricultural, light commercial. It does get used in the appliance world. Almost all interior pre-painted products are polyesters. Door frames, window sills, things of that nature will be a polyester. And I always like to point out to people that if you want to understand the diversity of a polyester, and that is a chemical type, a chemistry type, that term, think about the polyester clothing you wear versus a polyester paint on a building. Same chemistry family, same basic chemical reactions taking place, but two very, very different outcomes in the end product. So wide gamut there. Silicone modified polyesters are usually referred to as SMPs by their initials. So these are polyesters that have had a silicone intermediate reacted into the resin. This addition of silicone helps with durability and fade for exterior uses. So you get really good resistance to shock and fade. Again, you still have a wide range of colors and glosses available. But it is a little bit lower cost than the PVDF Kynar systems are. And we see SMPs being used predominantly in light commercial and residential applications for roofing and sidewall. And then we get to the fluorocarbons, the PVDF. This is sort of the Cadillac of pre-painted systems here. Go by different names, but they all reflect the exact same chemistry. PVDF is actually a very close cousin. It's one atom removed from Teflon. Most people can wrap their head around Teflon and how durable a product that is and its reputation. So this is very, very similar in nature. It's exceptional chalk and fade resistance. It does well in aggressive environments, great chemical resistance, excellent formability. And we see this in almost all big-scale commercial and architectural applications. So just to go back over that real quick, that was a lot. Sort of good to better, and sort of the pros and cons here. Durability, polyester is good. It can range from okay to great, but then the SMPs and PVDFs tend to be better. The warranties for polyesters vary from none to a moderate, and then you get longer ones as you step up in paint system. There are AIA specifications that govern the performance of all of these. Those are listed at the bottom, the 2603, 621, 2604, and 2605, depending on substrate. So, you know, how do you decide on paint, right? We've just gone over all these options. So not all polyester systems are the same. Wide range there, so it really depends on the end use. The differential these days in performance between a high-end polyester and a silicone-modified polyester can be quite marginal. The high-end polyesters have gotten very, very good over the years, and that has to do with pigmentation and resin chemistry has improved. But the PVDF, so the Kynar, is still really the best for exterior durability and warranty. Reminder that the Kynar 500 and the Hylar 5000 brand of PVDF is a trade name. The paint companies who make these products have to be licensed to use Kynar or Hylar and to call it by that name. It has to make up 70% of the overall resin composition, and that is tightly monitored. A word of caution, so that the Kynar and Hylar licenses are issued to a company for a specific geographic region. So just because someone has a Kynar license, say in China, to make Kynar paint, doesn't mean they can sell it here in the U.S. as Kynar, and vice versa. So sometimes we run into that certain offshore suppliers don't necessarily have the licensing for the United States. So we haven't broke for questions, and that's my fault. Do we want to take a quick pause?
I do have a couple of questions. Thanks, Michelle. And a couple of people are asking if you could just move the mic a little bit farther away. It's picking up some of the breath. Try and dial this incorrectly. All right. So we have a listener who's asking about Galvalume, and her understanding is Galvalume has a plastic coating on it. And is it possible to get it without the coating? And the reason she's asking is because they harvest rainwater from their roofs, and they prefer not to avoid having any plastics get into the water.
So I think probably what she's referring to is the clear-coated Galvalume. Most Galvalume, it's called bare, but it's really not. It has a very thin, clear resin applied to it. It's not plastic per se, but it is a coating. Yes, you can purchase it without, but the downside to that is it fingerprints really bad, and it may be difficult to roll form into the finished part. However, there are those clear resins that are safe for water catchment and runoff, and they get used for that all the time. So there are environmentally friendly options for that clear coating that most suppliers have access to.
So that's just something that the architect would have to specify during the specification
you
process.
Want to have a discussion. Yes, absolutely.
Okay.
Yeah.
Okay.
And my recommendation would be to ask for a RoHS compliant coating, which means it's not going to have any hex chrome or any of those other things that are sort of bad guys in it.
All right. And one more question before we move on. Another listener is asking about can 10-year-old Kynar metal panels be refinished on site?
The short answer is yes, assuming that there's not any extensive corrosion or other issues with the metal. Yes, field painting can occur. There's actually air-dry field-applied Kynar that can be used if that's what someone wants to go with. It's sprayed on. They usually come in and do a power washing or a sandblasting of the older panels, clean them up, lay down an air-dried primer, and then an air-dried top coat over the top of it. We see that in remediation fairly often, or buildings that have had some sort of damage, or buildings that are 30, 40 years old even. You don't usually see it as early as 10 years, but 30, 40 years out, there might be excessive fade or wear. It needs to be recoated.
Excellent. Those are the questions for now. Thanks very much.
Okay. Thanks. Is the sound better, I hope?
Yeah, it sounds better to me. I think there's a bit of variation across the audience and what people are hearing.
Drifting back towards its initial position. Yeah. So we'll move on here. So next is we're going to talk about enhancement options for pre-painted metal and what those look like, some of the different options. So what are the important building considerations that influence the type of pre-painted metal specified? Can be a lot. This is a pretty broad subject. So proximity to salt water, which is a corrosive, aggressive environment. Building efficiencies, energy efficiencies can come into play. The color, the visibility of the roof surface and line of sight from other buildings and viewers can be a problem. Glare, too much glare off of a roof. And then the mix of materials. What other materials might come in contact or be used on this building that has pre-painted metal on it? So it's a wide variety. We're certainly not going to be able to cover them all, but we wanted to cover sort of the more common ones that come up. The first would be mica and metallic pigments. These are really popular in the architectural world, right? So you get that sparkle, shiny effect, the silvers, the champagnes, the golds. And there's some cautions that come with those. They get used a lot, but they need some special handling. There's clear coats available. The clear coats can offer everything from extra protection in an aggressive environment to enhanced abrasion performance if you're in a place where there's a lot of blowing sand, for example, out in the desert. There's marine and industrial enhancements. Marine is pretty self-explanatory. Industrial would be like mining operations, chemical processing plants, things of that nature, where the building's going to be exposed to some kind of bad fallout or fumes. Graffiti resistance, this is a big one. There are coatings out there that not only resist graffiti, but are easier to clean. Cool roof, that's energy efficiency. Textures, and then prints and patterns. All things that can be done on pre-painted metal. So the mica pigments, which are added to the paint, are sort of pearlescent and shiny in nature. We used to have to use metal flakes, actual true metallic flakes, to get this look, but they had performance issues, and everyone pretty much switched to micas. But they're still called metallics in the industry, so those terms are used interchanged. You can get shifting colors too. So you guys have probably seen there's cars now being painted. There's a few buildings out there that have a color shift as you walk around it and the viewing angle changes. That's almost always done with a mica type pigment. But here's the do not do part when it comes to micas. So the size and orientation of these pigments cannot be completely controlled in the coil coating process, the way that they lay out. So you can't mix batches, and you gotta, for one job, it all needs to run at the same time because it's directional. And you can see some examples here The building on the left, that roof, that was actually all the same batch of material, but they swapped some panels 180, and you get that directional difference in look. And same on the right. It's not as noticeable, but they installed some of those panels backwards, as it were, and you can see a shift in color. So that's really sort of on the installers to make sure that they keep track of that well. And then we've got extreme environments. This is probably the special sites that come up the most for us in the pre-painted metal world, and this would be marine environments, industrial environments, where it's a corrosive air atmosphere, or they're spraying salt water of some sort that might come in contact with the building. So these are addressed by boosting up the primer that's underneath there. So there are special high build primers with extra corrosion protection. Then you put your regular top coat down, but then they almost always have a clear coat on top as well to help give them that extra layer of corrosion protection long term. So it's typically a 3 or 4 coat system, which means it has to go back through the paint line twice. So there's a little bit of added cost and time to get those done. But it is a warrantable finish. It may not be as long as a, quote, normal location, but there are warranties available for that. So the clear coats and graffiti resistance, these are quite fascinating. So the clear coat goes on top to provide the added protection, either to help with UV fade, resistance, or corrosion, but also to help with graffiti, right? So some of the new clears that are out there, it's really hard to get any other coating to even stick to them in the first place. And then if something does stick, they're very easy to clean and get that graffiti off. Word of caution on clears, not too big of a deal, but you will get a slight shift in the visual color with and without a clear. It tends to yellow it just a tad. This will be more visible on a lighter color than a darker color. But, you know, if you find yourself working on a job where that needs a clear coat, make sure you ask for color samples with the clear coat so you know exactly what it's going to look like. The pictures there represent standard on the left. The middle is with the high build primer, which really doesn't affect color much, and then with the clear coat on the right. And you can see that the white samples at the top has shifted yellow a little bit. The yellowness of the clear comes from the semi-transparent UV blockers that they have to use in that coating, so it has long-term performance. If it was truly clear, it wouldn't hold up outside and would delaminate. So now we move on to backers. This is the paint that gets applied on the backside of the finished product. It's often sort of overlooked and not really considered, but it can be important. It's usually an off-white or a light tan color. It is, you know, applied consistently, so it looks the same. Open, pre-engineered metal buildings, you can see the backside of the panel, so it needs to look decent and be consistent. Eaves and overhangs that could be exposed, you want that backside to look good. We also use these backers for adhesive properties, so foam insulated panels. That backer has to be able to take that foam insulation and adhere to it, so those are formulated specially for that end use. It also helps with corrosion protection, and when the coil has been painted and rewrapped, that backer helps limit any abrasion or scratching that might occur within the coil while it's being handled and transported. So now on to cool colors, a subject we spent a lot of time on, as Paul mentioned in the introduction. So cool colors came on the market back in sort of late 90s, early 2000s. So these are the coolness of these systems and heat comes from the pigmentation. So the pigments were altered chemically and physically to reflect in the infrared range of the light spectrum, which is where most of the heat comes from. The near IR region is what generates heat on a surface. They were able to do this without dramatically altering the visual color of those pigments. So they were able to take dark browns and blacks and greens and blues and keep them in the same visual color space, but alter them so that they reflect this near IR region. It's become sort of the standard anymore. Just about every standard coil coating pre-painted metal paint uses cool pigmentation now. It's become, you guys are probably all familiar, it's in the specs, especially out here on the West Coast and the Southwest. It's a requirement on painted metal. And it truly does help build up or minimize heat buildup and reduces cooling costs in hot climates. And also the outside temperature of the building. As one of the first feedbacks we got when the product was launched is that the installers were quite happy that while they still get quite hot, the panels get hot in the sun while they're installing them, it wasn't quite as intense as it was with the old systems. So there's several terms that come up in the cool pigment world, and you will see these in a lot of the specs and regulations. And that's the first one is solar reflectance. It's the amount of solar radiation reflected off the surface. It's expressed as a percentage usually. Emissivity is the amount of heat a surface can dissipate away from itself. So, okay, it's gotten hot, but how quickly can it try to cool itself off? That's important. And then the SRI, or Solar Reflectance Index. This is a calculation of the first two values with some wind airflow constants mixed in. It's a very long calculation. The Cool Roof Rating Council is sort of the go-to third-party verifier for these properties, and not just for pre-painted metal, but any roofing or wall type of coating or substrate that needs to be listed gets checked by them. One really nice thing about pre-painted metal, because it is so incredibly durable and our colors don't fade or change over long periods of time, is that this initial SRI that it might have, it's going to hold for years and years and years, whereas other types of roofing products especially tend to degrade very quickly in the first few years, and that the benefit that you're getting drops off right away. But with pre-painted metal, it really doesn't. So the 3-year age value is what most agencies list. So this is the, right, the higher the SRI, the better, but that's somewhat dependent on your color as well, right? Lighter colors obviously are going to have a higher SRI than dark colors, even with cool pigmentation. And you can see there, this is the new LEED guidelines for low slope and steep slope. Low slope is pretty high, has to have an initial SRI of 82. That really limits you pretty much to whites, maybe some very pale tans and grays. Steep slope, you have a little bit more room to work with. Initial SRI of 39 is going to give you some medium colors. It used to be 29 for LEED. When they raised it to 39, some of the darker browns and grays sort of dropped off as being usable at this point. But I can assure you that the pigment companies and paint companies are working on this diligently, trying to get those darker colors up in SRI value. So the other reflectance value that comes up a lot is light reflectance. And light reflectance and solar reflectance do get confused with one another quite a bit, but they're very, very different. So solar reflectance is all about that near infrared region, not visible light. Light reflectance value, LRV, is about the visible light that you see off of the surface. We typically call it glare, right? So metal, even painted sometimes, can be quite shiny. So you get a lot of glare and light reflection off of it. It is expressed as a percentage from 0 to 100. Lighter colors will have a higher value than dark colors on average. But there are ways to adjust this, because glare and shininess can be objectionable on a final installation. So you can play with texture, and there's ways to get a more matte finish by putting additives in the paint. And that is controlled by what we call gloss and sheen. So these are two properties that we can actually measure on any painted surface. Gloss is the measurement of visible light at a 60-degree angle. Sheen is measured at 85 degrees visible angle. So a high gloss, high sheen value, you're going to have a very high glare or high shiny surface. But low gloss, low sheen will be very flat or matte in appearance and not as shiny. So we have some examples there of what that looks like. So at this point in time, most of the standard paint systems for building products, exterior building products, are probably in the 10 to 20 range for gloss and sheen. We've seen that number come down over the years for a couple of reasons. One, because as it gets used more in residential, people, your neighbors don't want to be blinded by your roof, so that's a problem. And it's an issue around airports and military bases too for aircraft. They don't want to be blinded by a building on the ground they're trying to operate. So, but if you get the gloss and sheen down to 8 or less, which is quite low, you get a pretty matte finish with not much light reflectance on it. So the textures that are used, and these are gaining in popularity, it's done a couple of different ways. It could be the actual paint chemistry itself through a chemical reaction, or an actual, particle that's added to the paint to give it some texture. Sometimes you can feel the texture; it's that thick. Sometimes you can; it's like a micro texture within the paint. So then that takes us to other types of visual enhancements, and these two have become quite popular in recent years, and that is printing or print patterns. They typically mimic some other natural product like granite or a natural patina look, maybe a brushed look on stainless can be mimicked with paint. So it's the same paint systems that are used for a solid color, but you have special printing rolls that have been etched or cut to give you the pattern that you want. Wood grain is another one that we see a lot out there that gets used. And then there's laminates. Laminates are printed imagery that's then bonded to the metal surface. You can get some really crazy patterns. You can see some examples there. It can look like brick, or I've seen grass or bamboo or stones. Doesn't quite have the flexibility and durability of regular painted product. The film bond is not as strong as the baked-on paint systems. But we see these a lot for doors, especially garage doors. Do some laminates. Interior doors do laminates quite a bit. And then there's a new way of printing imagery, digital printing. This is it's like regular digital printing on paper, only scaled up for these coil lines. And so they're high-end inks and paints being used. It's like a giant printer with all the different dyes, and you can program in the image that you want, and it'll print it on the metal surface. But I went a slide too far. It's actually a fairly new process, and there's only 1 or 2 lines currently in the world trialing it, but sort of exciting to see how that develops. And I'll stop again. Any questions on that section on aesthetics and enhancements?
Hi, Michelle. We have a couple of questions have come in. Okay. One of them is about SRI numbers and what range is kind of the industry standard, and then the listener's asking what rating is LEED or better.
So I don't know that there's an industry standard per se. I think most paint formulators at this point are targeting an SRI of 25 or better to consider it cool. And that comes from the original Energy Star specs from many years ago now, where 25 was sort of the starting point for cool. But the new version of LEED for sloped roofing is a 39 SRI, so they have bumped it up. So for LEED purposes, to get that credit on a steep slope, it needs to have an SRI of 39.
Great. Thanks. And a second question here about low gloss. Does it have a greater chance of retaining dirt and dust?
Not typically. It's an excellent question, and it comes up a lot, and it was a very big concern when they were first developed. But no, dirt pickup for most of the systems that I've got experience with are not a real concern. And actually, the paint companies take the time and spend the money to put panels out in a site in Arizona that's very dusty and windy, and they actually do dirt collection assessments over time. And there doesn't seem to be any significant difference between the textures and a flat finish for the most part.
Great, thanks. That's it for right now. Thank you.
Okay, so we will move on to durability issues and warranty coverages, which is very important, not only to architects, but to the building owners, right? You've got this beautiful painted product. You want it to last, hopefully. So what are the three common elements warranted on pre-painted metal products? Those are, if it's a Galvalume product, the 55% aluminum zinc product, you would typically have a corrosion performance component in the warranty. And then for the paint, you would have film integrity and then chalk and fade. And those three things are usually called out within the warranty itself. Let's talk about durability first and what that means. So the pre-painted metal warranties right now are run the gamut from nothing, 5 years and up. I mean, we're seeing 40, even 50-year warranties now for high-end painted systems. It's usually for excessive chalking, excessive color fade, and then delamination of the top coat or primer, which is what film integrity means. There's an example there. This was a project done in Japan many years ago where they, on their own building, put up different paint types to see how they would weather over time. We did not talk about acrylics today. Acrylics are not really suitable for exterior building products, but you can see over time how well that the Kynar system did compared to the silicone polyester and the regular polyester. Now, this is an extreme example. They did choose a type of blue, that sort of aqua blue, that is more prone to fading than some other colors because they wanted to get a result fairly quickly. So why would there be failure, right? Why would there be chalking or fade or delaminations? And there's a lot of root causes for that. It can be improper application or installation of the building itself. It could be a bad paint formula. It could be an issue that the coater, the coil coater had. Maybe they didn't get the right film. Maybe they didn't cure it correctly. And there could be environmental conditions as well. Is it corrosive? Is something happening at the site that's affecting this paint in a negative way? So excessive chalking, it's just what it sounds like. It's when a painted surface gets white and chalky and there's this white powder on it that you can actually usually wipe off with your hand or a rag. What's occurring there is that the resin particle or the polymer backbone is being broken down by UV exposure into little short segments and then can come off the surface, bringing the pigment with it, which is why you get a lightening or a whitening effect. This used to be an issue, but I would say in the last 20, 25 years, even the polyesters, the lower end polyesters, the technology and the pigmentation has gotten so good that we rarely see excessive chalking in the field anymore. It just doesn't happen very often. But the warranties, the high-end warranties, are typically 20 years or more for this defect. There is a rating in ASTM test that dictates what excessive chalking is. The higher the number, the better in this case. So a 10 or a 9 on the scale means that there's really no chalking occurring at all. Color fade is probably the biggest one and probably the most important one in the exterior building world, right? We don't want it to fade, or we don't want it to fade too much over time. So fading, of course, is when UV degrades the pigments itself. Color change is measured by a delta E value, a numerical value that we use an instrument to measure. The human eye, average human eye, can start to pick up a color difference in the 0.5 to 1 delta E range. The Kynars, the PVDF, tend to have the least amount of fade and are warranted as such. The pictures here show you the top sort of, these are lab prepared samples that show you the difference from starting point at the top to 5 units delta E and then to 7 units delta E. So you can get an idea of what that fade looks like over time. It's really not as great as most people think. The roof at the bottom is something we run into quite a bit. This is a situation where an installer mixed 2 different paint systems on a roof. So most of the roof was a polyester, but there were a few panels of higher end Kynar that got mixed in and used. So those have held up and not faded, but the rest of the roof has started to deteriorate. And it's not an uncommon thing where there's been a mix of products on a job site. So the panel manufacturers and the installers, that's on them to make sure that that doesn't happen. The other thing we notice with color fade is that if the color fade over time is pretty even and consistent, usually no one complains. We usually get color fade complaints when, like with that house in the picture, part of the roof is doing fine and part of the roof is not, and it becomes obvious that something's going on. But if you're 30 years in on a roof and it's faded pretty evenly, probably not going to get a warranty complaint. And the last one is film integrity or delamination. This one we do see it's a tough one to determine root cause. This can be either the top coat coming off and away from the primer, or the entire paint system coming off the metal substrate for some reason. It's usually a bubbling or peeling. Sometimes you get little chips and cracks that show up. And again, a lot of reasons for this, but the most common would be low film. So that would be the coater not having applied the right amount of paint to the surface. An incorrect pre-treatment, so you don't get a good bond of the paint to the substrate. Inadequate curing of the paint system. Some kind of incompatibility between the top coat and the primer. We've seen that where the, quote, wrong primer was used under a top coat, so there's not a good bond. The one we see the most of is mechanical damage. And in our world, mechanical damage means any kind of exterior force that has occurred on the surface to cause an opening in the painted surface that then leads to delamination. So scratching during installation or afterwards, fasteners maybe not being done right that tear through the surface, and then now there's a little opening where moisture and ice over time or whatever can get in there and cause that paint to start coming off. My favorite example of this is a field warranty claim I worked several years ago where in Lake Tahoe at the high school, they were complaining because there was all these scratches and paint coming off the roof. So we went up there and looked at it, and in the process of looking at it, we were informed that in the wintertime, the students snowboard off the roof of that high school with their snowboards. So that certainly would explain why there would be scratches in the painted surface. So those are sort of the things that are covered in warranty, but there are other types of failures that occur that aren't necessarily a warrantable failure, but issues that we see out in the field that we need to be cautious of. And this would be dissimilar metals or incompatible materials being used with the pre-painted panels, Swarf or metal filings that are left and not cleaned up at the end of a job, and then storage corrosion. So either in coil form or the panel is being stored in a wet or hot environment before they go up on a building can lead to corrosion and issues. And then there's also oil canning, which is a shape issue that can occur. So dissimilar metals, probably the biggest one we see is near the ocean, which is considered a corrosive environment. So there's salt-laden air or fog or rain. And it's all about the galvanic scale. So the further apart two metals are on the galvanic scale, the more prone they are to have this type of corrosion and contact. And what we see a lot is stainless steel components being used with the zinc loom or galvalume substrate on buildings. So this particular case here, this house was about 200 feet off the surf break in La Jolla, and they recessed the stainless steel light canisters through the painted galvalume panels. And you can see that ring of corrosion that is occurring around there. Now, if this weren't next to the ocean, it probably wouldn't be a problem, but since it was right on the ocean, it became a pretty big issue. We also have concerns with concrete. So the moisture that's held in concrete up against galvalume can be a problem. There needs to be a barrier between the two so that the moisture can't work its way into the galvalume panel and attack the aluminum component that's in there. And then chemically treated wood can be a problem, especially because it's often treated with copper compounds, and copper leaching out of the wood onto the painted metal will cause premature corrosion. So the example at the top here is concrete. The wall on the right is concrete, and then the galvalume panels on the left You can see the corrosion blooming out from those contact points. They did not use a water barrier between them. And then this is a chemically treated deck, and where the water was running off the deck, we were getting corrosion down below on the panels at the next level. But as soon as you got away from that deck, it was fine. Swarf, metal filings. This is an installation issue. So these are little, when they're drilling and cutting on a site, putting fasteners in, and you get little shards of metal left over. If they're not cleaned off the surface, those start to rust. But the complaint that comes in is, oh, my metal panels are rusting. Well, the metal panels aren't rusting. It's what got left on the surface that's rusting. And it's very, very hard to clean off after the fact. So during installation, they need to be very diligent about sweeping and cleaning these up as they go before they start to rust and leave these ugly rust stains on the painted surface. So we have all kinds of recommendations around the type of power saws and blades that should be used. It's best to cut on the ground if you can. Cover the area around any drilling and cutting if possible, and then cleaning up routinely. And then wet stack or storage corrosion. So this is when the panels are packed tightly together and don't have a lot of airflow and moisture builds up between them. That moisture actually penetrates through the painted surface to the substrate and will start the rusting or corrosion process because it's trapped. And it presents as these little tiny micro blisters of the painted surface. So there's a whole bunch of technical bulletins on how best to store material before it gets put up on a building so that this doesn't happen. Oil canning is a shape issue that occurs. Almost all light gauge steel, especially, is prone to this. It's one of the downsides of it. But so basically, it looks like an oil. It waves. You get buckles in the panels during installation. The causes include stresses in the base material. So if that base underlayment's not done right, you can get this effect. Improper fastener pressure. So if you're over drilling and pulling the panel too tight in one direction or forcing panels together because they're misaligned, you'll get this buckling or oil canning. There is thermal expansion that plays a part. It may look worse at certain times of the day than other times. There's a couple ways to combat this. One is making sure that the roll forming process is done very, very good, and that the shape of the panel is ideal. But you can also add stiffener beads or striations to the panels to help take some of that shape out. Embossing the surface helps as well, minimize that. And then lower gloss coatings, which we just recently talked about, low gloss, low sheen, that matte finish masks this quite a bit because you're not seeing that reflection off the surface. So how do we avoid these type of failures? So using the right paint and having the right paint specification for the environment and the end use is very important. You want to use a reputable coil coater with really good QCing practices. You don't want to mix batches or types of products. A good manufacturer who's roll forming good panels and packaging them appropriately to go to the job site. And then an installer who's familiar with working with metal and how to cut it, how to handle it. And then cleaning. Most of the warranties do have a cleaning and maintenance schedule built into them. Again, I like to use car analogies, is that most people don't keep their car their entire life and not ever wash it, right? It would be a disaster. But same with roofing and siding. It should be washed off periodically. So what does a coating warranty look like? We have some examples here. They're all, everyone's sort of got their own format. But again, you really want to see what are they warranting, right? So usually there's some duration at the top. It's 30 years, it's 20 years, it's 25 years. Okay, well, it's great, but what's being warranted for that duration? What does that mean? How long is the film integrity? What's the color fade delta E that's going to be allowed? What's the shock rating that's going to be allowed over time? And sometimes the initial duration at the top, 40-year warranty, sometimes that only applies to the film integrity, and it's reduced for the fade and shocking. So you really do need to read through the whole warranty, which a lot of people don't. And then there's a lot of other things, right? There's, like with any product warranty, if you've ever taken the time to read one, it's about 10% of the document is what's warranted, and then the other 90% is all the exclusions and things that will void the warranty. So it's always good to read through those as well to see what's not covered long term. But I always like to point out here that pre-painted metal, aluminum and steel for the outside of buildings is typically with a PVDF coating going to have anywhere from a 20 to 40-year warranty on it. And we've already talked about what an incredible thin amount of paint that is, which is pretty remarkable that it's expected to last as long as it does. By comparison, the typical paint warranty on an automobile, and automotive coatings are sort of often held up as the pinnacle of paint. Keep in mind, it's 5 times the thickness. That warranty for auto paint is typically only 7 to 10 years in reality. So it's a fraction of what we're offering for building components. So a big difference. So again, this is checking to see what you want in the warranty, what's being warranted. And then also the other thing to stress is what's the remedy, right? If there is a failure, what's the manufacturer going to do to fix it? And that can vary quite a bit between suppliers as well. Marine applications, severe environmental applications or sites typically have to have a pre-approved warranty. It's not going to be your standard warranty, and most suppliers have a process for that to go through. So I think I'm only a couple minutes over. We're at the end. We've covered a lot of information. I'm not going to read back through it all, but we did cover a lot as far as what is paint and the specifics of it and the warranty. So are there any questions?
Thanks, Michelle. Yeah, there are a couple of questions. I recognize we're over, so I'm gonna take one of these questions, which is asking a practical application of some of this, and maybe ask you to kind of respond to it and put that into the larger context of the course. So what the listener's asking is, they have to replace some metal pan stairs with new metal stairs in an covered but an open stair towers. Stair companies are offering to deliver products primed, galvanized, or powder-coated finish. Can you put what's the best option there and why? And I think maybe that'll kind of wrap up a lot of things you talked about today.
Yeah, so stairs would be a special case because of the heavy traffic they're going to have. You're going to need much more paint and a much more a different kind of paint on it than you would for panels. So I would think powder coating or primed and then field painting with a heavy, air dry type industrial coating would probably be best. It's going to be quite thick because you need it to hold up to that foot traffic. We've been asked before actually if pre-painted, the type of pre-painting that we do could be used for floors and stairs, and it really can. It just doesn't have enough coating on it to hold up. But powder coating is usually quite good.
Just not abrasion resistant enough for the traffic.
Yeah, I mean, it's just, And of course, being exposed to who knows what's going to be on the bottom of it, right?
This person does say, well, it's also a coastal location to make it even better.
Yeah, that's even,
Okay.
So you're going to want a good heavy primer and then a good heavy field applied top coat or powder over it,
Well, not quite the broad practical application I was hoping to get into, but a good information. I do want one clarification. You mentioned a technical bulletin on panel storage. Is that from the National Coil Coaters Association? Where could the listeners find that?
They do have one. NCCA has a bunch of technical bulletins around a lot of different topics, but most of the manufacturers have adopted that NCCA bulletin for storage as well, and you can find it on most websites. Steelscape's got their version. Most of the panel manufacturers have their version, but it is all based on that NCCA. They call them toolkits. They've got a bunch of them on different topics.
Yeah. What a great presentation. Thank you so much, Michelle, for taking the time to give us a huge variety of information. Really appreciate that. For our audience, if you want more information, you can go to steelscape.com. You're also going to receive an email tomorrow with links to a web page where you can view this webinar again. I understand there were some folks struggling with audio and a couple even with the visual in their locations. You can see it again. You can also in that place download the presentation so you can dig into some more of the technical information that Michelle presented today. In that email, there'll be information about CEU credits. But thank you all very much for attending. Thank you, Michelle, for a great presentation. We're doing another webinar on August 21st at 1 o'clock. That title of that webinar is Sustainability plus Metal Roof and Siding, and it's presented by AEP Span. Thank you all very much. Have a great day, and thank you, Michelle.
Thank you.